Yep, thank you for saying here. Remind everybody else, please do the same. We'll give everyone a few minutes to get in. All right, so guess we will get started. First thing of note, please remember that you have a test currently up, so please don't forget about that. It closes today at 5 p.m. So make sure that you log into WebAssign and have already done that. Okay. Let's see. What else? Okay. So I guess we will go ahead and jump in. Happy Friday, everybody. So last time we were talking about functions. Specifically, we're starting to get into analyzing graphs of functions. But we have already talked about, sorry, I don't want to knock over all my junk. So functions and their graphs. So some of the qualities of functions we've talked about so far are zeros of functions. Actually, that's the fancy spelling. So we'll just say zeros. This is basically just setting the function equal to 0 and find x. So this is probably the most common quality that we're used to, but it is a function or a quality of functions in general. So talked about how we plot functions. We talked about the domain and the range. So the domain is the allowed x values that make it make sense. And the range is similarly the allowed y values. So we're going to talk a little bit more about the qualities of that the graphs have. And one particular bit is where a graph is increasing, decreasing, or constant. So at this level, it still is, we're still kind of building up all the tools that we're going to need. So exactly what these things mean is a little bit vague, but to show you just a picture of what I mean, you have something like this. So this is our function, this is a graph, and over this interval, it's a decreasing function. This interval, it is constant, and this interval, it is increasing. So again, exactly what this means won't be especially clear until you get to calculus, but it is still an important quality of functions. So even if you don't know exactly how it's increasing or decreasing, whether or not it is tells you something. So this is where we're going to jump in. All right. So we're going to try and come up with a set of algebraic principles to figure out if a function is increasing, decreasing, or constant. So let's first look at the graphs. If a function is increasing, we usually describe this as what it's doing while you go from left to right. So function is increasing if it goes up from left to right, decreasing if it goes down, and constant if it's flat. Okay. So I've written a couple of, just drawn a couple simple lines here. What is something that we know to be true about these lines? Let's look at just this one specifically. What is something that no matter what the actual numbers are that describe this line, we can still tell something about it? So what is something that we know has to be true about the equation for this line? Anybody? Feel free to speak up in voice or on the chat bar.
Looking at it, I'm assuming that it's going up.
It's going up, yeah. But what does that mean about the equation for that line? What's the equation for a line? What's the equation for any line in general? Not good. So this is the equation of a line. So what is something we know is true about this equation? Well, let's find the slope. slope equals y2 minus y1 over x2 minus x1. So we don't know what what y1 and y2 are, but we do know something about them relative to each other. Y2 is above y1, so you have to go up. What does that mean about the numbers y2 and y1?
Is it delta y?
Well, this is delta y, but if this point is higher than this one, what does that mean about the number? If this one is 2, what is about, or I'll give it, if this one is 5, what has to be true about this number?
It's greater than.
Say it.
It's greater than the other number.
It's greater. No matter what this one is bigger. So we know that y2 is greater than y1. This point is further to the right than this one. What does that mean about the x values of this one relative to this one? If you're further to the right, what does that mean about your x value?
Farther.
Do what?
It's farther than the other x.
Yeah, so this one's x value is further to the right than this one. But what does going to the right do to your x value? If you start at 5 and you go to the right 5, what is your new x value? We start at 5 and we go to the right 5. 1, 2, 3, 4, 5. What is that? It's 10. So if this one's x value is further to the right, that means that its x value is greater than the other one. So if you subtract a small number from a big number, you're going to get a positive number. And if you do the same on bottom, you get another positive number. So what we can tell about this thing is its slope is positive. Period. Or when its x value increases, the y value increases. So delta x is positive, and delta y is positive. How about on this one? We're still going left to right. So we're still increasing our x value, but our y value is going down. So delta x is positive. Then delta y and this last one, when you go in the positive x direction, what is delta y? What is the change in the y value? What is the change in the y value from here to here?
It'll be positive.
It's not positive,
Negative.
and it's not negative, because that was the other two ones. First one was the change in y is positive. The second one, the change.
They'll equal each other.
The two y's equal each other. So what is the change in something if they are equal to each other? What is 5 minus 5?
Nothing. 0.
It'll be 0.
So this is how we algebraically compare these different types of functions. Is we look at an interval and we say, well, as we go from left to right, meaning our change in x is positive, as we go left to right, what does our y value do? If it goes up, meaning it's positive, that means it's increasing. If it goes down, our change in y is negative, then it's decreasing. And if it doesn't change at all, then it is constant through that interval. So this is what it means to have increasing, decreasing, or constant behavior. So this comes up when we talk about, sometimes it's referred to as end behavior, or let's see, they have a different name for it. End behavior of a function, or if we're talking about the evenness or oddness of a function. So I'm going to draw a couple basic functions. All right, so these are kind of what the graphs of these functions look like. Like this. All right. So for our first function, y equals c, some number, we just have a horizontal line. This goes across. Y equals mx plus b is a line. X squared, ax squared plus bx plus c is a parabola. And then y equals x cubed is a cubic function. So to determine whether a function is even or odd, we look at what the function does at the two ends. So look at function going to negative infinity and positive infinity. So let's take one that we know very well, the line. What is this thing doing? What is the y value doing as you go to negative infinity? So as we go to the left, what is the y value doing? Is it going up? Is it going down? Is it not moving? So it's going down. So when it goes to the left, it's decreasing. When it goes to the right, it's increasing. So the two ends of the graph are doing the opposite thing. Let's look at this one. As we go to the left, the y value isn't changing at all. As we go to the right, the y value isn't changing at all. This one, go to the left, the y value goes up. This one, as we go to the right, the y value goes up. This one, go to the left, and it goes down. Go to the right, goes up. So we look at what the two end behaviors are relative to each other. So this one, they're both doing the same thing. This one, they're doing opposite. Right over there. This one, they're doing the opposite. This one, they're doing the same. And this one, they're doing opposite. Okay. This is where we get the even or odd thing from. So odd graphically means ends are opposite, and even ends are doing the same thing. Where this comes from, this even or odd, is the leading power of each function. So this one is odd, and it's because the highest power of a variable is x to the 1. This one is even because the highest power is x to the 2. And then this one is odd because it has the highest power of x to the 3. And this one is kind of a redheaded stepchild where it's technically 0 isn't really an even or an odd number, but it fits a lot of characteristics of even numbers. So in this context, we call this, because this is actually x to the 0 times c. So this one is even. This is how you tell graphically whether a function is even or odd. And algebraically, if f of x so f of negative x is negative f of x, or for evens, f of negative x equals f of x. So this is even versus odd. So let's see, we've got about 3 minutes. So Let's see. Any last minute stuff we can throw in here? Yeah, we'll just do minimums. So minimums and maximums, or minima and maxima. So we'll have graphs that might do something like this. So a relative minimum or a maximum, relative maximum, means that relative to the points around it, it is bigger or smaller than all of those. So at this top of the peak, we have a point right here that is higher than the ones next to it. So it is a relative max. And then in this trough, we have one that's lower than the ones near it. And that is a minimum. As for the math behind it, just means that the y value in the middle is greater than the y values on the outside. And same is true for the other sides. We'll start back with this on Monday. But please remember to do your tests. All right, you guys have a good evening.